Okay guys, lesson 21. We're going to talk about finally graphing tangent. No one's asked me that question. I'm sure if I had you in class, you'd probably have been like, hey, Mr. Griska, what's the graph of tangent look like? And then, we would talk about it. But we're going to talk about the graph of tangent. It's definitely not an Algebra 2 topic, the graph of tangent, but I definitely want to show it to you. In the background, oh my goodness, this is great. This is Atlantic City, New Jersey behind me. Now, I got a great story about Atlantic City. I was robbed in Atlantic City twice in a 2-week time frame. If you haven't heard that story, next year when we get back to school, stop by. I'd love to tell you sometime. It's a classic. So tangent. All right, well, what is tangent? All right, so I got my tangent shirt on. As far as geometry is concerned, the tangent is that line that just barely touches the edge and then goes off. That's why I got the, sometimes I have to go off on a tangent shirt on. In trigonometry, tangent is sine over cosine. It's also opposite over adjacent as far as SOHCAHTOA goes. But tangent is also the idea or concept of, kind of going off into a random thought or rant about something, or thinking about something that just arbitrarily comes into your head. Okay, I'm back and refocused. So now, there's the unit circle again, right? You haven't seen that in a while, but let's go around the unit circle and just remind ourselves about tangent values around the unit circle. Remember that tangent is your sine over your cosine. So when we go to all these different values, we just take our sine, which is our y value, put it over our cosine, which is our x value, and figure things out. So the tangent of 0 is right here, so that's going to be 0 over 1, which is just 0. The tangent of 90 is going to be 1 over 0, which we call undefined. The tangent of 180 is going to be 0 over negative 1, which we can call 0. And the tangent of 270 down here is going to be negative 1 over 0, which is also undefined. So tangent is undefined at 90 and 270. Now remember, 90 is really pi over 2 when it comes to radians, and 270 is 3 pi over 2 when it comes to radians. So the fact that tangent doesn't exist or is undefined at 90 and 270 makes the graph very interesting. So I'm going to show you a picture of what tangent looks like up here. I'm going to do from negative 2 pi to 2 pi, just so you can see the whole thing, get the full experience, and we'll go from there. So I have my graph all set up here. I got negative 2 pi up to 2 pi done. So let's just remember that pi over 2 is really 90, and 3 pi over 2 is really 270. Tangent doesn't exist or is undefined at those two spots. So what does that graph look like? Well, what we need to do is we need to make sure that this graph doesn't exist in those places. So we set up what's called an asymptote. And I'm not sure if we use that word prior to us departing ways from COVID-19, but I'll tell you what an asymptote is here in just a second. So right here at pi over 2, what we do is just put a dotted vertical line in here just to indicate that tangent can't exist there. It's not allowed to be there. All right, and this line is called an asymptote, and we'll get to what that's called or why that's called that in just a second. That same thing is going to happen here at 3 pi over 2. Now, you need to remember that negative 90 is the same as 270. They're the same angle. Like when you go to negative 90, that's the same as going to 270. They're the same. So there's going to be an asymptote or a place where tangent doesn't exist right there as well, and one at negative 3 pi over 2 as well, because negative 3 pi over 2 is up here, which is really the same as 90. So, okay, so we got our what are called our asymptotes, and I'll get to what those are in just a second. But now let's talk about tangent and what it looks like, all right, in all of this. So if you grab your calculator, you don't have to do it because I have mine in front of me right now, but if you take the tangent of an angle that's really close to 90, which is the same as pi over 2. So I'm going to switch my calculator to degrees, and I think I might already be in degrees. I am. So I'm going to just do the tangent of an angle that's really close to 90. So I'm going to do the tangent of 89 degrees. And when I hit enter, I get a really big number, 57 point something. So the tangent at 90, or almost 90, 89, is like really high up here. And in fact, if you get even closer to 90, like if you try to do the tangent of 89.7, which is even closer to 90, look at that. You get an even bigger answer, 190 something. So what's happening is as tangent gets really close to 90 degrees, it gets really, really tall, all right? And it starts to get really, really close to this line right here, but it never actually touches it. So like if you get the tangent of 89.99, look at that. Huge number, right? So we can continue to take the tangent of numbers that get really close to 90, but we're never going to touch that because we can't actually do the tangent of 90. So what does that all look like? All right, so what happens is tangent goes up and it gets really close to this 90 degree mark, but never touches it. And that's called an asymptote. And I think we might have talked about that back in whenever it was we were back in school. But that's what happens over here on this side. Now on this side, the same idea is going to happen over here. It's going to get really close to negative 90, but it's never going to touch it. So that's what that section of tangent will look like. And what happens is that same exact shape repeats itself throughout the rest of the graph. So right here it comes up and goes like that. Over here, all we're going to see is this part of it. We're not going to see the rest of it because we only went up to 2 pi. It's going to, same thing's going to happen in between here. And then over here, we're going to see the, not the side where it comes up, but we're going to see the rest of it over here that goes like that. So that's what tangent looks like. It's a really weird looking graph. And if you try to graph tangent on your calculator, because these calculators are very limited with their graphics, it's going to look really sloppy and messy. You can put it in there and graph it if you want to look at it and see it, but the calculator doesn't have the ability to draw these asymptotes right here as dotted lines. It draws them as solid, so it looks really jagged. It almost looks like a heartbeat when you're looking at it. But if you have a newer calculator, yes, it's going to be okay. All right, so what I want you guys to do for homework is I want you to explore some of the other graphs of things that you're going to see in pre-calc that you don't see in Algebra 2. Because again, I'm trying to get you ready for that. I want you to look at the graphs of cosecant and secant. And in a second, I'm going to erase this and put up the settings for the calculator so you know what to set them to. I'm going to show you how to put those graphs into the calculator. And I want you to just look at them and see what they look like so that you're familiar with them. And next time when you're in pre-calc, you have an idea. So the first thing you want to do is make sure your calculator is back into radian mode because we do all our graphs in radians. So make sure your mode is switched to radian. Hit the window button on your calculator. Remember, window is right here. Window, hit the window button. When you hit that, you got all these options here. And these are the settings. I went through this in one of the lessons a while ago, but here's your X-min, X-max, X-scale, Y-min, Y-max. I used 5 and -5 as my Y values. You can use whatever you want. You're still going to see the picture. And what I'd like you to do is I'd like you to graph secant and cosecant. Now, you're going to see that on your calculator, there's not an actual secant button or a cosecant button. All right, so how in the heck do you put in secant and cosecant? Well, when you go to y equals on your calculator to put in your graph, we should know that secant is the reciprocal of cosine. So if you put in 1 over cosine, so 1 divided by the cosine of x on there and hit graph, you'll see a picture of cosecant. And then I also want you to do that with, sorry, that was secant. I also want you to do that with cosecant, and to do that, you're going to do 1 over sine x because they're reciprocals of each other. And I just want you to look at those pictures, see if you see any asymptotes showing up anywhere, places where the graph is undefined. I just want you to explore that. That's it. I don't want you to do anything more than that for homework. I just want you to see it so you can be exposed to it and know what it looks like for next year. If you want, you can put some numbers in front of your x value right here, change your b value. You'll see more cycles of it occurring, just like we do with sine and cosine. But either way, there is just some quick stuff to explore. And after that, we're going to be just about wrapped up with trigonometry, I think, here. I'm going to start talking to you guys about exponents and logarithms. So for those of you that took skills or are taking Algebra 2 again, you love logarithms. They're so fun. But we got to do exponents first to get you ready for logarithms. All right, I'm done going off on a tangent. Stupid joke. All right, see you.